We've learned about formula expressions. Now let's take a look at a very important aspect of statistics, namely explaining variation. So here we look at penguins, the penguins data set, and within that we see that there is variability in the mass of penguins. In other words, not all the penguins have exactly the same mass. There is variability. So now we can ask a question, why do we see this variability? Okay, at the first level, we can say, well, you know what? Different species of penguins are of different sizes. Some species tend to be smaller, other species tend to be bigger, etc., etc. So, obviously, in our collection of penguin data, we have penguins coming from different species. So, obviously, we're going to expect some variability in the size of the penguins or in the mass of the penguins. Okay, so the fact that we have penguins of different species explains to some extent the variability of mass of penguins. Okay, then we ask the other question, the next question, which is okay, I agree. I have penguins of different species and therefore I'm observing different masses of the penguins. However, even if I restrict my attention to just one species of penguin, even within that, I'm seeing a variation in mass. Well, why is that happening? Then we have a question, you know what? The penguins with different bill lengths have different masses. And here you see, even within a single species, we are seeing penguins with different bill lengths. So obviously, you're also going to see penguins with different mass. Okay, so here we are not saying that bill length is causing the penguins to weigh more or to have a higher mass. No, that's not what we are saying. We are just saying that bill length and mass seem to be related. And because we have, even within a single species, you've got penguins of different bill lengths, naturally, you're also going to see penguins with different masses. Okay, so then we ask the question, well, what explains the variation in mass even within a species and a given bill length? In other words, if you take all the penguins and take all the penguins of a particular species, within that species, if you take all the penguins that have exactly the same bill length, you're still going to see that there is variability in mass. Well, why does that happen? Then we ask a question. Then we see, oh, you know what? Not only are these factors determinants of mass, however, sex of a penguin also determines to some extent its mass. So obviously, even though we have isolated all the penguins of one particular species, and within that we have taken all the penguins that have exactly the same bill length, we are still seeing some variability in mass because some of these penguins that we have selected are male and some of them are female. And uh, the penguins of different sexes also tend to differ in mass. Okay, so this is what explaining variation in statistics means, right? So we are saying, you know, some variables are related to other variables. In other words, the mass is related to the species. So if you're going to see penguins of different species, you're going to see penguins of different mass. Okay. And then we say, well, bill length is also related to mass. And if you're seeing penguins of different bill length, you're going to see penguins of different mass. Or sex is related to mass. And once again, if you're going to see penguins of different sexes, you're going to see some variability in mass as well. This is what the notion of explaining variation in statistics means. Okay, so that's what we've just discussed, all of these ideas. Okay, so now let's look at what this explaining of variation, how it helps us. Okay, so suppose somebody comes along and says, hey, I've got a penguin, it's of X species. We are told only the species. Okay, so now you can still have an approximate idea about its mass because we know that species, penguins of one particular species tend to be heavier than penguins of another species. So given, and also the average mass of penguins of a particular species hovers in this particular range. So given all that, the moment I'm told I've got a penguin of a particular species, I have a somewhat of an idea of its mass. Not accurate at all, but we know roughly in the ballpark. Okay, it helps us a little bit along the way of knowing its mass. And then somebody comes along and says, hey, here's the species of penguin I have, and here is the bill length of this particular penguin. Okay, that gives us an even slightly better idea about its mass. Okay, so that's what explaining variation does. It helps you in terms of your uh, having an idea about a particular case. Okay, so you've got species and bill length variables. They tell us why we see penguins of different mass. They tell us the variation in mass. Okay, a specific penguin is heavier than average. Why? Because its species is X and it has a longer than average bill. Therefore, this particular penguin is also heavier than average. Okay, so that's explaining the weight of a particular penguin. Okay, so that's the whole idea. So that is why species and bill length are called explanatory variables, because they help us to explain the variability in mass. The variability in species and the variability in bill length help us to explain the variability in mass. Okay, so this is a plot we had seen earlier. So you've got the species on the color, and then you've got the bill length on the x-axis and the mass on the y-axis, and clearly you can see the chunks of data. Okay, so even for species of given bill length and mass, bill length and species, right? If you take penguins of a given species and given bill length, okay, so here's the species, you take a particular bill length, you're still seeing a lot of variability in mass, right? Even for a given uh, bill length, right? So this is all penguins of one particular species. You fix the bill length, and still you're seeing there's so much variability in mass. Okay, so what explains that? Okay, so to be specific, Adele penguins with a bill length of 40 still show variation in mass. Okay, so species and bill length explain some of the variability, but not all of the variability in mass. Well, could we add in some other explanatory variable that helps us to uh, explain this variability? Well, why not try to add the sex of this penguins? Okay, so this time we use the point plot. We say mass tilde bill length plus species. Earlier we had this. Now we also add sex, right? And when you add a third explanatory variable, then uh, you see that a point plot function automatically divides the plot into two different facets. These are called facets. Okay, so here is the plot for all female penguins, and here is a plot for all the male penguins. Okay, so clearly you can see that uh, you take penguins of this particular species. For females, they are here. For males, they're slightly higher, in the sense that the male penguins of that species are slightly heavier. And the same thing applies to all the species, actually. Okay, so that variability uh, uh, is further explained by the sex of the penguins. Okay, so each of these are called facets. Okay, so when you have three explanatory variables, as here, right? So this is your response variable, and these are the three explanatory variables. So we already know that the first explanatory variable, the response variable goes to the y-axis. The first explanatory variable goes to the x-axis. The second one goes to color, and the third one goes to facet. This is how uh, the point plot function works. Okay, so given species, bill length, and sex, we still see variation in mass, right? So you take a particular bill length, Okay, and the species is given let's say this species, take a particular bill length, take a particular sex, you still see variability in the mass. Okay, so female adult penguins with bill length of 40 still show variation in mass. Right? So, like I said here, there is variation. All of these penguins are of the same species, and if you draw a vertical line, they are all of the same bill length, and yet we see variation in mass. Why is that? Well, maybe age is a factor, right? Penguins which are older, maybe uh, heavier, etc. So, okay. So we can ask the question, is the variation less than that for male adults with 40 bill length? So here is female adults with a certain bill length of 40. There is this much variation. If you take the males and take a bill length of 40, okay, it looks like for the same species, the variability among males is actually more than with females, right? So for females, you see the variability is going from here to here. That's the range. For males, for 40, the range seems to be much higher. Okay, so that is something that we are learning by doing this plotting. Okay, so that's the plot here. So we've got uh, here without the sex, we understand something. But the moment we bring in sex, we understand even more. Okay, so each of the variables that we have considered, bill length, species, sex, all of them have some power to explain the variation in mass. Okay, so later in the course, we will precisely quantify exactly how much of the variability is explained by each of the variables, each of the explanatory variables. Okay, so here we had uh, sex on the facets and color, species on the color. Now we could do it differently, right? We could switch it around and put sex as the color, and we could put the species in the facets. Okay, information conveyed is the same, just allows us to look at the data slightly differently. That's all. Okay, so this is only for the adult species, and you've got male and female. Similarly for this the chinstrap species and the gentoo species. Okay, so it's we are able to see clearly that uh, the penguins of this particular species are generally heavier, and the males are heavier than the females. And these two species of penguins have pretty much the same mass. Okay, very slight difference. So you see that the female masses are in this range and the male masses are in that range. Okay, so these two seem to have similar profile in terms of their mass and the relationship between bill length and mass. They look almost the same, whereas there is a clear difference with respect to this Gentoo species. Okay, now when we do point plots of two categorical variables, so if you do this, for example, births 2022, point plot, married versus uh, 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 male education. Okay, so now both of these are categorical variables. So if you just plotted them normally, obviously at the intersection of a particular M-educ and mother's education and married status, okay, there will only be one point here. Okay, the reason we are seeing so many different points is because point plot automatically jitters the points. Otherwise, this is one point, that's one point. So anything that has this profile of this education level and married, all of them will fall exactly on the same spot. Okay, but to help us to visualize this better, a point plot jitters the points, moves them around a little bit so that we can get an idea of how many points there are. So for example, we see that there are very few points here, whereas there are lots of points here and somewhat less number of points here, etc. That's the point of jittering. Okay. Okay. Now, of course, even with jittering, there is still quite a bit of overplotting that's going on. To reveal that better, okay, we can do, uh, right? This is the plot when we just do point plot of species versus sex. Okay, but here we are adding another thing that says point inc equals point 0.2, right? So here every point is colored black, completely black. Whereas here we are saying make it a little bit transparent. Okay, so that if you add 5 of them, then it becomes totally black. Okay, so now you can see here that there's some amount of gray, and this helps us to better visualize how many points there are and how much of overplotting is going on, right? So for example, in this, these two look almost the same, whereas here we are able to make out a difference of the amount of overplotting that's going on here. Quite a few points are plotted here, whereas here there's not as much overplotting. So likely there are more points here. So that's what point inc allows us to do. Okay. Now it is possible for us to map color to a numeric variable as well. Not a great idea in general. Okay. So here we are saying uh, we are putting bill length as your uh, uh, the target variable. Okay, a response variable, and then we're putting bill depth on the x-axis, and we're putting mass as the second argument, so that goes to color. Okay, so note what it did. It took the mass, which is a numerical variable, right? If you assign color to a categorical variables, then to every category it can assign a color. Whereas here we made mass as our color variable, so it automatically split up the mass into different ranges and assigned a color to each range. Okay, it does add to some extent. It adds helps our understanding. So, for example, here you see here that uh, all these penguins with this particular small bill depth and this particular bill length, they're all of uh, a uh, certain mass and so on, right? So here we are seeing the lighter penguins are here, the heavier ones are there, and so on. Okay, but in general, when you map a numerical variable to color, it's generally not very useful. If at all there is an option, you should map categorical variables to color.